Well, hello there, algebra students. This is Mr. Vaughn back with some more algebra. Today we're going to be learning how to solve quadratic equations using completing the square. All right, so the way we're going to do it, we're actually going to do this in two different videos. So for this video, I want to just kind of solve the same quadratic equation using a method that we've already learned, zero products, and the method that we are currently learning, completing the square. That way you can see that it works. All right. So the cool thing about completing the square is that it can solve any quadratic equation. All right, which we'll find out later in the next video. Zero products is limited. All right. So let's take a look at this one. We have x squared plus 4x plus 4, and we want to solve this by zero products. All right, so if you remember the process here, the first thing we have to do is we have to make sure it's in standard form, right? In order to be in standard form, it has to be in descending order, which it is. A has to be positive, which it is, and it has to be set equal to 0, which it's not. So we need to turn that 16 into a 0. Now, how do we turn a 16 into a 0? It's very easy. You just subtract 16, right? If you got 16 bucks, I can turn that into a 0 real quick. Just go out and spend it. Okay, do that to both sides. All right. So 16 minus 16 is 0. So we end up with x squared plus 4x, and 4 minus 16. Well, those signs are different, right? So they're going to be subtracted. So 16 minus 4 is 12. And you keep the sign of a larger number, which is minus. It's a negative 12. So if you got $4 and you lose $16, you're in debt $12, right? And that's going to be equal to 0. So now we have it in standard form. All right, so now we have this trinomial. Do you remember how to factor a trinomial? Well, the first thing you have to do is see if there's a greatest common factor. When we look here, they don't, well, this is a 1, right? That's a 1x squared. So they don't have a number in common besides 1, and that doesn't count. Do they have an x in common? Well, these two have an x in common, but this one does not. So they do not have any greatest common factors, so we can just go straight in to the AC method. Okay, so I'm going to draw my x here. Let's draw it off to the side here. So A is 1, right? So A is 1, B is 4, and C is negative 12. That's my ABCs. All right, so here goes AC, A times C. Well, 1 times negative 12 is negative 12. And B goes right here, and that's going to be 4. I'm going through this rather quickly because we've already learned how to do this in another video, but it's also always nice to just kind of rehash and refresh. Okay, so I got negative 12 and 4. So now I need to come up with two numbers, then multiply to give me negative 12, and we'll add or subtract to give me 4. Okay, so let's think of all the factors of 12. Okay, I have 12 times 1, I have 6 times 2, and I have 4 times 3. Okay, so 12, all of these will multiply to give me 12, or negative 12, but only one will give me 4. Okay, 12 times 1 is 12, but 12 minus 1 is 11. That's not going to work, right? So that's not going to work. 6 times 2 is 12. 6 minus 2 is 4. Ooh. 4 minus 3 is 1. 4 plus 3 is 7. So 3 and 4 won't work. So it looks like 6 and 2 are the two numbers that I want. Okay, now the question is, what are their signs? Okay, well this is a negative 12, right? So that means one of the signs has to be negative. The question is, which one's negative, the 6 or the 2? Well, let's see. 6 minus 2 is 4. Ah, that's how we want to do it. So 6 times negative 2 is negative 12. 6 minus 2 is 4. So those are the two numbers we want to use. And so we would just simply factor this. Let's set up our parentheses, set that equal to 0. To factor x squared is just x times x. And then we use our two numbers here. So it would be what, plus 6 and minus 2. So we have x plus, this is the factored form. Okay, and remember the principle of zero products? If you have two numbers multiplied together, or two terms multiplied together set equal to 0, one of the terms has to be 0. All right, so that means I can set this up as x plus 6. This term has to be 0, or x minus 2 has to be 0. All right? In other words, if you multiply two numbers and the result is 0, one of the numbers has to be 0. So I'm just setting both numbers or terms up to 0. And now I just simply solve these little equations, which is easy to do. X plus 6, I just undo the positive 6 with subtracting 6. So that's going to be 0. So then I get x equals 0 minus 6 is negative 6. So there's one of my solutions. Now I go to my other equation here. I have x minus 2 equals 0. To get rid of a minus 2, I just add 2. Do it to both sides. So that's going to cancel, leaving me with x equals 0 plus 2 is 2. So there's my other solution. Okay, so remember I have up to 2 solutions with quadratic equations. And there they are, okay? So I could solve that using principle of zero products. Okay, I can also solve it by completing the square. Question though, could I solve this by using principle of square roots? Well, remember, to use principle of square roots, the b term has to be 0. That cannot be there. All right, so if it was like that, then yes, I could use principle of square roots. Because I have that b term, that's kind of off limits. I can use completing the square. Okay, so if you remember from the last video, in order to have a perfect square trinomial, you remember the little formula? C had to be equal to b over 2 squared. If that is true, then I get a perfect square trinomial. Okay, let's see if that's true in this case. Okay, C, okay. What's b? Well, b is 4, right? So that's going to be 4 divided by 2 squared. 4 divided by 2 is 2, and 2 squared is 4. So C equals 4. Is that what my C value is up here? It is. So my C value is already 4. Therefore, this right here, if I were to draw that, it would be a nice, perfect square. Now, what's the significance of that? Well, you're going to see in just a moment. All right, so let's go ahead and factor this thing. Okay, so we know that, well, let's just use a little x right here. So let's just ignore that 16 for now. We don't even have to put it in standard form to do this. Okay, so AC goes here and B goes here, correct? So AC, 1 times 4 is 4, and B is 4 as well. Okay, so what two numbers multiply to give me 4 and add to 4? Well, you guessed it. It's 2. All right? So 2 times 2 is 4, and 2 plus 2 is 4. Okay? So then we can just factor this. Let's erase that. So x plus 2 and x plus 2, and that's all equal to 16, right? We have not put this in standard form. Okay? One of the cool things about this is you don't really have to have it in standard form. Okay, so now I want you to notice something. I have x plus 2 times x plus 2. Do you know of a shorthand device to write a number that's being multiplied by itself? So for example, if I said 3 times 3, is there a shorthand device for that? There is. It's just 3 to the second power, right? So if I have x plus 2 times x plus 2, I can write that as an exponent. This is just simply x plus 2 to the second power, isn't it? Yeah, it's just x plus 2 times x plus 2. Now I'm going to set that equal to 16. All right? So, now what? Okay, well I got that exponent there, don't I? If I could get rid of that exponent, my life would be a lot easier. But I know how to get rid of exponents. Do you remember what the inverse of a square is? That's right, it's a square root. Okay, so I'm going to take the square root of that left-hand side, and I'm going to take the square root of the right side. As long as I do the same to the left and right, I'm good. Okay, what is the square root of x plus 2 squared? Well, remember the square root and the square are inverses. They undo each other. So I'm left with simply x plus 2. Ooh, nice. X plus 2. Now, what's the square root of 16? Okay, most of you are probably saying 4. But remember, it has two solutions. 4 times 4 is 16, but negative 4 times negative 4 is also 16. Right? So I have to write it as plus or minus 4. Okay? All right, now I can finish solving this. So I have x plus 2 equals plus or minus 4. This right here is actually two numbers. It's a plus 4 or it's a negative 4. There's two numbers there. Okay? All right, so let's go ahead and I want to solve for x. So to do that, I just need to subtract 2 to both sides. So let's go ahead and do that. So I subtract 2 to the left, and I'm going to subtract 2 on the right. These 2's are going to cancel. All right, and so I'm going to be left simply with x on this side. All right? Now, here's a little bit tricky, but not too bad. Remember I said that plus or minus 4, that's actually two different numbers. Okay, this is actually 4 or negative 4. All right, there's two numbers there. So if it is 4, I'm just going to cover that minus sign. All right? If it's 4, okay, what's 4 minus 2? It's 2. There's one solution. Okay. But what if 4 is negative? Instead of a positive 4, what if it's negative 4? What's negative 4 minus 2? Well, a negative plus a negative is going to be even a bigger negative. All right, so that's going to be a negative 6. So x equals negative 6. All right, did I get the same answers? I did. I did. So I can solve this particular quadratic equation by either using zero products or by completing the square. Now I know what you're thinking. You're thinking, Mr. Vaughn, I've already learned this. I like zero products. I'm going to stick with that. Why do we need to learn a new method? Good question. You'll learn in the next video that not all, in fact, many quadratic equations are not solvable by using zero products. Okay? However, you can solve any quadratic equations using completing the square. All right? So stay tuned for our next video, and I'll show you an example of where it doesn't work with zero products, but it does work with completing the square. All right, so until next time, make sure you subscribe to my channel so you get notified for all of my new videos. Until then, may God richly bless you.